Hi guys, welcome to my channel. This video is dedicated to example problem 3 in the Unit 6 Lesson 4 packet. So let's get started. We are asked to calculate the pH of a 0.075 molar solution of the weak base ethylamine, C2H5NH2, and the Kb is equal to 6.4 times 10 to the negative 4. Okay. This question is pretty straightforward, but some key information is the molarity of our solution, the fact that we have a weak base, and of course it's Kb. So let's start by setting up our rice table. So I'm always going to start with the reaction. And because I am working with a weak base, I cannot use a simplified dissociation reaction. I have to show it reacting with water. So C2H C2H5NH2 reacts with water to form C2H5 NH3 plus OH minus. The reason I cannot use a simplified dissociation equation is because there is no way to show this producing hydroxide without reacting it with water. There's simply no source of hydroxide inherently within this compound. Now I'm going to continue setting up my rice table. I'm just going to cross out the water column because water is a liquid, and so it does not affect equilibrium, and I'm not interested in it. My initial concentration of ethylamine is 0.075, while we can assume the initial concentration of the conjugate acid and hydroxide are 0. The reaction can only shift in the right direction because there are no products present initially. So my ethylamine will change by minus X, while my conjugate acid and hydroxide change by plus X. My equilibrium row is going to be essentially the sum of the initial and change rows. And now that I have these terms, I of course need to somehow relate them to each other. And the way I'm going to do that is by using the Kb and Kb expression. So for this specific reaction, Kb is equal to my concentration of C2H5 NH3 plus times OH minus all over my ethylamine. My water is, of course, excluded from my base dissociation expression because it is a liquid. My Kb is equal to 6.4 times 10 to the negative 4. My conjugate acid is X. My hydroxide is X. And my ethylamine is 0.075 minus X. Again, we are working with a weak base, so we can assume that the extent of dissociation is very small, and our change in our concentration of weak base will be negligible. So we're going to assume that this is negligible. And so I'm going to get rid of this term so that I do not have to use a quadratic. Cross multiply and take the square root to determine that x is equal to 0.0063693. So let's add this into our braces table. Cool. Now I know the equilibrium concentrations of all of my species. However, I have not actually answered the question, which is to calculate the pH of the solution. Okay, so here's the deal. I am working with a base. So the species that is being produced is not hydronium, it is hydroxide. So in order to get the pH, I have to first calculate my pOH and then convert that to pH. So pOH is equal to the negative log of the concentration of OH minus pOH is equal to the negative log of 0.00693. My pOH is equal to 2.16. And then I can use the relationship between pH and pOH, namely that the sum of the two of them is always 14, to calculate my pH. And I get that my pH is equal to 11.84. That's all for this video. See you next time.